So for the next topic, we'll talk a little bit about circles and the equation that determines the circle and things that we can do with circles. So remember, a circle is the locus of points at some distance, let's call it R, from a given center C. So let's draw what that looks like. This is my X and my Y axis. If I put my center here, and let's say this is my radius R, then the circle again is all the points that are at distance R from the center. Okay, that's nice enough. So let's calculate what a circle looks like. So let's take a point P on the circle and let's give it coordinates X and Y. And what we know is that the distance from that arbitrary point P to the center has to be equal to R. And if we write this out, and before I do that, I should give the center some coordinates. Let's call it H and K. So with these coordinates, I then have that the distance is the square root of the difference of the coordinates, so x minus h squared, plus y minus k squared, square root of that equal to r. And now to get rid of that square root, we will take the square, so square both expressions to get x minus h squared plus y minus k squared is equal to r squared. This is also a very important equation. When you want to deal with circles, you're going to encounter this equation in some way, shape, or form. So let's look at a couple of examples to get some idea of how this works. So for the first example here, I want to find the equation of the circle that has points 1, 1 and 7, 9 as endpoints of a diameter. So if we make a drawing, then if this is the point, let's call it P with coordinates 1, 1, and this here is the point Q with coordinates 7, 9, then we want this line segment to be a diameter of the circle. So our circle is going to look a little bit like this, and this is tricky for me to draw. Like this, and then like that. So, given that this length is a diameter, what do we know? Well, the midpoint, the center of the circle is going to be the midpoint of this line. So let's call this C. C is the midpoint of the line segment PQ. And this is great because we have a formula for coordinates of the midpoint. We know that the coordinates are the sum of the x's, 1 plus 7 divided by 2, and the sum of the y's, 1 plus 9 divided by 2, So that gives me 8 divided by 2, or 4, and 10 divided by 2, or 5. So this tells me that the coordinates of the center are 4, 5. And now the radius, let's call it r. For that we can take any point on the circle. Let's take P, and it's the distance from the center to a point on the circle. So it's the distance from C to P, let's say. And we know this is equal to the square root of 4 minus 1 squared plus 5 minus 1 squared, square root of 9 plus 16, and that then becomes equal to square root of 25. I know you can simplify that to 5, but I will need the radius squared. So from both of these put together, we get that the equation of the circle becomes x minus the x coordinate squared plus y minus the y coordinate of the center squared equal to the radius squared. So that's 25. And now you can work this out a little bit, but I will not do so. I'll just leave it in this form. Let's do another example here on the right hand side. So for the second example, we'll find the center and the radius of the circle with the following equation: x squared plus y squared minus 6x plus 2y plus 8 is equal to 0. So first of all, you might say, well, is this even a circle? Doesn't look like what I had with the sum of the two squares. And that's a good impulse. At this point in time, I can tell you it is a circle, and we'll see why in a second. So let's write this equation a bit more spread out. Let's collect everything in x. So we have x squared minus 6x. And now let's collect everything in that has a y in it. So then we have plus y squared plus 2y. And here let's put all the constant terms. So plus 8, that's equal to 0. So same equation, just written over a couple of lines. And why do we do that? Well, now we can see we have to find something that looks like x minus a constant squared. So let's try to make this into such a square. So what we can do here is we can add plus 9 here and then subtract 9 here. And likewise, we can do plus 1 here and then minus 1 here. And why do we do that? Well, if you look at this expression for a little bit, what you'll get is that this then becomes, you can write this as x minus 3 squared, and you can write this as y plus 1 squared. And so now if you collect everything, we get x minus 3 squared plus y plus 1 squared, and then constants here, let's bring them to the other side. We get 8 minus 10, and that gives us 8, 2. So from this, we conclude that the coordinates of the center are 3 minus 1, and the radius r is equal to square root of 2. So keep in mind, first of all, what you have here, that's the radius squared. And then secondly, what you have here, it's always x minus the coordinate of the center. So here this plus 1 means that the coordinate is